Hello friends, welcome back to our channel STM32 So in this video we will see the calculator project and basic functionality of the calculators. Okay, so the code is like we have interfaced the keypad and a LCD. Now in our previous projects we have interfaced these two also, keypad and a LCD, but the functionality was something different, right? So in this project we will do the keypad calculator functionality. We will mention it here. But as you see, STM Mechatronics has been displayed. Okay, so now we'll come over here. Okay, we'll add some key functionalities. Okay, so first we'll check the add functionality. That 1 plus, let's suppose I'm taking 528 or 579, some random number. Okay, and then I'm pressing 1. So 1 plus 579 is equals to 580. First we'll see all the basic functionality and whether our simulation is working properly or not. Okay, later and we will check rest of the functionality. So any number we can take. This time I will be taking some long number. Okay, okay, so 8642 plus 8974165, right? And so we will do first calculations on our calculator. 8642 plus 8974165. Okay, so we should get our answer is equals to 8982807. Now we'll check our answer, right? 8982807. Now this decimal number is something that we need to take care of. This is kind of a bug. Okay, so this is our limitation because I have handled the floating point calculations in the code also, so that's why it is kind of showing as a buggy. Okay, we will remove those errors also. In later part we will remove the errors also. Okay, now we'll go with the subtract functionality. I'll keep this fairly simple for now. Okay, so yeah, we are getting the subtract functionality now. So whenever we are pressing equals to sign after after certain delay, okay, this whole functionality will get cleared and we can do the new functionality. Okay, into, let's take 15. So this is square of 15, 255. So we are getting 255. Okay, now let's do 625 divided by 25. That is, we will be getting the square root of 25. Okay, so yes, so we have seen that all the four functionalities are working properly. Okay, so that's the first part that we have connected. Okay, so the agenda of this project that we will be going through, or the topics that we will be covering in this video will be: first, we have seen the simulation is working correctly or not. Okay, so before starting this explanation, I need to show that the simulation is working properly or not. Okay, now we have seen the limitations also, that this is kind of a bug. Okay, there is kind of a bug that we need to resolve. I'll upload the video to resolve the bug, how I resolve this bug. Okay, now coming to this, now we have to see that the pin configuration of STM32. Now open your STM32, go to file, new, STM32 project. Here STM32 F103. Oh, sorry, here I need to put STM32F103C8. C8. Okay, C8T6. Because in our Proteus simulation we have this controller STM32F103C8. Okay, so we can do our simulations on this controller. That's why I am selecting STM32F103C8. Okay, now once you select this, click on next. Okay, give the project name, and then click on next and finish it. Okay, so I have already created my project, calculator project. Okay, that's why I won't be doing that step, but for your but to show how we are creating a new project, just follow these steps. Okay, now once you click on finish, you will be routed to this screen. Okay, in which we will get the pinout and configuration. Now there are 4 tabs: clock configuration, project manager, tools, along with the pinout and configuration. Now see, first we need to do the connections over here in the Proteus. Okay, now go select the component STM32F103C8. Okay, C8, this you select. Okay, place it, then keypad, you select interactive keypad for calculator. Okay, so this keypad you can place, and then LCD. We are using 20x4 LCD because we want to show the data. Okay, data, result, and our project name. So that's why we are using 20x4 LCD. Then one common LED, red LED, and a resistor. I have connected switches over here just to show the 4-bit and 8-bit mode to interface with the LCD. Okay, so both pinout with both configuration, like I'll be showing that our code is working perfectly fine. Okay, so you can both use either of the both configuration. Okay, now place your keypad over here, connect PV0 to A, PV1 to B, PV2 to C, PV4 to D, then 5, 6, 7. Okay, 4, 5, 6, 7, you connect this 4 number pin to 1, PV5 to 2, PV6 to 3, and PV7 to 4th column. Okay, so PV0 to PV3 will be connecting to rows, and PV4 to PV7 will be connecting to our columns. Okay, now remember this, we have to mention this somewhere. Okay, so I'll be placing a text that PB0, this is row 1. Okay, now I'll go edit properties, control, then enter. Okay, PB1 to row 2, PB2 to row 3, and PB3 to row 4. Okay, so I'll add some spacing over here. Okay, now drag over here, copy, paste. Now for columns, column PB4, PB5, PB6, and PB7. Okay, so So this will be used for column 1, this is used for column 2, this is used for column 3, this is used for column 4. PB7 is used for column 4. Okay, so yeah, so pin connections are done like this. I'll show you the LCD pin connections. So D0 is connected to PA0, D1 is PA1, similarly D2, P2, D3 will be PA3, D4 will be PA4, D5 will be PA5, D6 will be PA6, and D7 will be PA7. Okay, so D7 will be PA7. Now this RS pin, okay, this is connected to PA8 and enable is connected to PA9. Okay, then so a right pin is connected to ground. Okay, so likewise you have to make the connections. VE connected to variable terminal of the potentiometer. Okay, and VDD is connected to 5 volt. This VSS is connected to ground. Okay, now these are the pin connection that we are going to follow. Okay, now remember that PB0 to PB3, these are connected as rows. Okay, so this is PB0 as output, PB1 as output, PB2 as output, and PB3 it is as output. Now column connections are made as input. Okay, so PB4, PB5, PB6 and PB7, these are connected as input. Additional two pins PB8 and PB9, these are also connected as input, configured as input. Okay, so if you want to extend the calculator functionality like sine, cos, tan, we want to add the trigonometry functions like sine, cos, tan, we want to have the multiple keys. So in that case we will be needing 2 more extra keys or 3 more extra keys, column keys. Okay, column pins. Now for LCD port, we are using port A, and this has to be configured as output port. So PA0 to PA9, this is configured as output port. One LED is connected to PC13. Okay, so if you are using a blue pill board, there is LED connected to PC13. Okay, so it is configured as GPIO output. We will be using that LED. Okay, now coming to this, now we will modify PA0 to PA9. This is configured as output. All these outputs are output push pull, and internal pull up has been enabled. Okay, so you have to configure output push pull and internal pull up. Okay, now PB0 to PB3, same configuration we have to do. GPIO mode output push pull and GPIO pull up, internal pull up has been enabled. Okay, for PB4 to PB7 and 8, 9, okay, we want to connect pull down. Okay, these have been configured as GPIO input, and we want to connect the pull down. Okay, now PC13, again output push pull and pull up register has been enabled. Okay, now coming to, we are not using any timers or like that, so we will be using internal RC oscillator, but we will be using the PLL. Okay, because we want to have the higher clock frequency. The internal RC oscillator clock frequency is of 8 megahertz, so we are using PLL. Okay, so divided by 2, this PLL clock source we will select, the PLL multiplier we will select as 8, then we will select this clock source. For a system clock we will select the PLL clock source. So 8 divided by 2 is equals to 4, 4 into 8 is equals to 32. So 32 megahertz of clock will go to the system peripherals. Okay, all system peripherals. So our CPU will run at 32 megahertz of clock. Okay, now if you see, like we have all the peripherals are running at frequency of 32 megahertz. Okay, now once you do this pin configuration, right, what you have to do is you have to click on generate device configuration. Okay, now once the device configuration has been generated, it will bring you to this main screen. Okay, now I have already compiled, I have already coded my program. Okay, I have already done my, I have already completed my program. So I will be walking you through my program. Okay, few things that we need to take care is, first thing we will be needing the LCD library. Okay, second thing we will be needing of the keypad library. So what I have done is I have already prepared this LCD libraries and keypad libraries. Okay, LCD libraries and keypad libraries. Okay, now coming to LCD library. First we will define which pins are used for which pin is used for RS, which pin is used for enable signal, then which pins are used for data lines. Okay, so PA0 to PA7, these are connected to D0, data 0 to data 7. Okay, so all these pins have been configured like this. So we have GPIO pin 0 to GPIO pin 7. Now it is the data pins are connected to port A. Okay, so pin port is configured as GPIO A, GPIO port A. Okay, now RS pin has been connected to GPIO PA8 pin, and enable is connected to PA9. Okay, that is pin port will be GPIO A port. For enable it will be same. For RS pin 8, for enable pin 9. Okay, so for RS signal it is pin 8, and for enable it is pin 9. Okay, so that configuration have been done over here. Now these are the LCD commands. Okay, so these are common commands that is already present. Okay, now from last video what we have done is we have added these two more macro definitions. Okay, so LCD 8-bit mode, LCD 4-bit mode. We can write as a enum value also, that is also doable. Okay, but we are using the macro definitions. From next video onwards we will be using the enum values. Okay, so now these are the declarations. Now coming to definitions, we have already gone through the LCD definitions more number of times. Okay, so I'll leave this part to you guys. Okay, so it is simple. LCD, like in which mode we want to connect. If we want to connect, give the command or data. If you want to print the data on LCD, we have to send 1 over here, and whenever we want to send the command, we have to send 0 in the parameters. Okay, in this LCD function parameters. Okay, so according to this command, right, this pin will set. So if it is RS pin will set is 0 to 0, then it will be considered as a command to LCD. If RS pin is set as 1, it will be considered as data by the LCD. Okay, now in which mode that we want to use. Okay, so this is LCD mode. Okay, LCD mode value. So if it is equals to C, we want to send this is the value, either the command value or the data value. Okay, so command value or data value that we want to send to the LCD. Okay, or we want to print on the LCD. Now whatever mode that we have selected, LCD mode. Okay, according to that mode, 4-bit or 8-bit mode will be selected. So we are using this global variable LCD mode select. Okay, so coming to this LCD initialization function, we are configuring D7 to D4 as output and the initial configuration at 0. Okay, so initial state is as 0. Then if we are setting the 8-bit modes, we are already configuring it as a pin low, logic low. Okay. So if it is 8-bit mode, we are sending 38 command, that is 2 lines 5 by 7 matrix. Okay. Else we will be sending 02 and 28 command. Then rest of the commands it will be following, that is clear the cursor, blink the cursor, right? So these are the commands that we use. We have gone through these commands many times. If you want to understand thoroughly, you can refer to the older videos. Okay. Now printing commands, 4-bit mode. So the difference in 8-bit mode is we are using all the 8 data lines, and in 4-bit mode we are only using D4 to D7, that is 4 data lines. So higher nibble will be sent first, right, and then the lower nibble will be sent. So in this case, in the 4-bit mode, we will be sending 2 enable pulses, okay, after a nibble is sent. Okay, so this is done. LCD functionality has been done. Now coming to keypad.h, right? Now PB0 to PB3 has been configured as output port, and those are connected to row. Okay, so these are connected to row. Now if you see, we have taken multiple pins, we have configured multiple pins as column pins, right? So I have told you that whenever we want to extend the calculator functionality, we will be needing a larger keypad, right? Keypad with larger keys. So in that case, the column numbers will increase. Okay. So for that we have kept the spare pins. For our simulation, we will be only needing these 4 pins. Okay. And for keypad, all the pins are all the ports are port B pins. Okay. So we have configured it like that. Now see. Now see, what we have done is, we have in the first row of the keypad, the first key is 7, the second key is 8, third key is 9, and fourth key is divide. Okay. So first key, first row, first column, that is 7, first row, second column is 8, first row, third column is 9, and first row, fourth column is divide. Okay. In this manner, we have already defined the keys. Okay, same goes for second row, then third row, then fourth row. Okay, so in second row we will be having 4, 5, 6 and multiply. In fourth row 4, 5, 6 and multiply. In third row we will be having 1, 2, 3 and minus. In third row we will be having 1, 2, 3 and minus. And in fourth row it is on off 0 equals to an addition. So in fourth row we will be having on off, either on off or root functionality. We have done that 0 equals to an addition. Okay, so in this way we have declared the macros, okay, for the keys that we are assigning. Now this is done in keypad.h. Okay, now coming to keypad.c. So the keypad key press functionality is same. Again, we are setting the keys first. Okay, then we are checking the which column has been pressed. So in keypad.h we have only 2 functions or 3 functions. First one is the keypad initialization, second one is key press, and third one is column check. Okay, so the logic behind that is, whenever any key is pressed, okay, let's suppose row 2 and column 2 key has been pressed. Okay, so what it will be doing is, it will pull this pin, or it will provide logic high over this pin. Okay, so logic high to column 0, and over here it will be 1 only. Okay, due to the strong pull up. Now we have to check which key has been pressed. Okay, due to which key, from one row, either from row 1, 2, 3 or 4. Because column 2 is high, that means the connection has been done, right? Either from these keys, 4 keys. So that we want to check, right? So what we will be doing is we will go sequentially. First we will, in the column check, we will reset all these pins. So it will be logic 0 0 0 0. Okay, so if any key has been pressed, so this column will go to logic 0. Okay, now what we will do is we will make this column high. We will check if the column 2 is still logic high, right? So after raising this row 1 to logic 1, is column 2 logic is equals to 1. So then it means row 1 column 2 key has been pressed. If not, means after doing this, or we or better, like, so this will be pulled high. Okay, this will be logic 1, this will be logic 0, this will be logic 0, and this will be logic 0. Okay, so we are considering that we have pressed key number 5. Okay, so this connection won't be complete, right? This connection won't be complete, so column 2 won't be connected to logic 1. So the value will be 0. The value will be 0. Okay, over here we'll consider two states, 1 and 0. Okay, so what we will do in our program is we will make this to 0, we will make this to 1. Okay, now 5 has been pressed, means row 2 column 2 key has been pressed, so the value over column 2 will be equals to 1. Okay, so by understanding this, we will understand that okay, column 5 key has been pressed. Okay, so in this way we are checking which key has been pressed. Okay, so that logic is written over here. I'll just slowly scroll through it. Okay, so if we are reading the key values, right, we are reading the column values. So we are reading the column values. If column 1 pin 1 is equals to 1, okay, then we will go check which column, which row has done this. Okay, so column 1 is 1, right? So we are reading the first column. If the column 1 is 1, we will check in which key has been pressed in column 1. Okay, so we will go like that. Then if column 2 key has been pressed, then we will check. If column 3 key has been pressed, then we will check column 3 keys. Column 4, then see, we have added 2 more columns. Okay, or else it will return a blank space basically. Now in check column, right, in check column it will go. Now it will set all the row keys to logic 1. Okay, then one by one it will reset. First it will reset, it will check that okay, this key has been equals to 0 or not. If it has been 0, means column 1 has been pressed. Column 1 row 1 key has been pressed. If it is not, we are resetting, like we are setting the column to 1, then row 2 to 0. Then we will check, okay, row 2 column 1 has been pressed or not. Okay, then we will send okay, column 2 row 2 has been pressed. So in this manner we will return the keys. Okay, then after doing all this check from which row which column key has been pressed, okay, we will again set the value to 1. So this is fairly simple to understand. Okay, so key detection logic we done. Now LCD logic that we have done. LCD logic we have done. Okay, we have already understood like which pins we are using for a keypad, which pins we are using for LCD. Now coming to the main part, that is arithmetic logic. Now what we have done is we have fairly understood that the how LCD will work, how keypad will work. Now we want to integrate both the functionalities. Okay, so we'll come to main.c. See, we can use this mat.h functionality also. Okay, that is the already the default C library or standard C library for math functions. Okay, or we can write our own also. Then we have added this lcd.h and keypad.h to libraries. Then we have used this arithmetic.h also. Okay, so this is the library that we have written. So if we go inside this, we have written the add, subtract, multiply, divide function, then reminder function, root functionality, sine, cos, tan functionality. Okay, now coming to this C functionality. See, we are passing this float numbers. That's why we were getting dot 241 something value. Okay, that is because we are passing this float values. Okay, then here we have already defined that if we are calling this function, that add function, then number 1 and number 2 will be added and the result will be returned. Same for subtract. Okay, number 1 will be subtracted from, number 2 will be subtracted from number 1 and the result will be returned. For multiplication, we will get the multiplication of number 1 and number 2. For division, so number 1 will be divided by number 2 and whatever value, okay, divisor value, that will be returned. Okay, in remainder we will be directly returning the remainder values. Okay, so in this way this arithmetic function has been written. Now this was also fairly simple, right? Now the main part comes that we want to integrate all this functionality. Okay, now we have this display float first, then calculator function, and then convert array into numbers. Okay, these three functions we have written. So we will be going one by one. Now defining the local variables for our main functions. Okay, so we have var key, previous var key, because we want to add the numbers, right? So let's suppose we have some large number. Okay, so 85461. So whenever we are pressing the key, it is getting stored inside the array element. Okay, so we want to convert that array element into some certain number. Okay, and for the same reason, whatever value that we have added or whatever previous key that we have entered, that must be stored, that must be known basically. So it serves two purpose basically, that if any operation key has been pressed and which operation key has been pressed, it will be stored in this previous key. So it serves the functionality. Now we have this default array which we display on the first row of the LCD. Now this we have the clear array. Okay, so if you want to clear the LCD, like whenever we are pressing the clear button of the keypad, then we will be displaying this message. Okay, then we have float number 1 and number 2. So basically we are performing addition, subtraction, division, multiplication and remainder of two numbers. Okay, we can do multiple numbers also. So basically whatever the results of the previous operation, that will be stored in number 1, and whatever number we are adding later, that will be stored in number 2, this variable, number 2 variable. Okay, so like in the arithmetic functions, we have written the return type as double. So in main.c, our result variable is of double type. Okay, then we have float variable also, that is of result1 variable, that is of float type. Okay, now we have num array which is of 10 length. Okay, so there is one more limitation that I am talking about here. So maximum of 10 digits we can store for the number. Okay, if the multiplication goes beyond the 10 number, only 10 numbers will be displayed. Okay, Now coming to the num counter. Okay, I'll explain the functionality of this num counter. Clear flag variable. So if you remember, at the start of the simulation I have shown that whenever we are pressing any arithmetic key, right, after few seconds, so after pressing any arithmetic key or the equal key, the result will be displayed, but after some time the LCD will clear all the things, right? So that for that purpose we are using this clear flag variable. So for that purpose we are using this clear flag variable. Okay, now coming over here, now halt delay. Okay, we will reduce this delay to 5. Then LCD. Okay, LCD 8-bit mode. Then keypad initialization. This is basic initialization. Now here we are displaying the first row, first column. Okay, we are giving this as a command, LCD as a command. Okay, now LCD string. This is the default string. Default string is what? STM32. That's why on the first row, from the first row, first column of the LCD, STM32 will be displayed. Okay, now we are giving the command that whatever next data we want to print, that will be printed on second line, first column. Okay, now coming to the main while loop. Okay, here we are setting the GPIO 13 of C port. So basically we are making the LED on, okay, which is connected to pin 13 of the C port. Okay, here we will check which key has been pressed, var check. So we are continuously checking which key has been pressed. Okay, so if the key, var key, is equals to fourth row, first column. So what is the fourth row, first column? This is on off key. Okay, so it will be displaying that clear the LCD, right? It will go to the second line, first column. It will provide the command. Okay, now we are providing the string. Which string we want to print is clear array. Okay, so basically it will provide clear all. This string it will provide. Then it will come over here and it will say clear flag is equals to 1. Okay, now we will see. We have written over here, if the clear flag is equals to 1. Okay, clear all these variables. So num1 and num2 values will be reset to 0. Previous value key var key value will be set to 0. Result value will be set to 0. Then clear flag will be reset. Okay, then num counter. Okay, whatever counter we have, basically whatever numbers that has been stored in the array, right, it will be cleared. Okay, and num counter is equals to 0. We are setting the num counter is equals to 0. Okay, so you remember, right, we can add only 10 digits number. So for that we'll have this num counter. So whenever we are adding, like whenever we pressed first key, right, then we press second key, then we press third key, then we pressed fourth key. So now we have 4 digit number, right? So to store that 4 digits into the array, we have this counter, num counter. Okay, now then LCD clear screen, that whatever has been printed it will get cleared. Then again it will go to the first row, first column. It will print the default array, that is STM Mechatronics. Okay, then it will go to the second row, first column. Okay, so this is the clear flag functionality. Now again coming back over here, if we are done with this, okay, now if the key pressed is equals to the assignment operator, right, or equals to operator, so it must print the result, right? Now we are, whatever number 2 that we have added or number 1 that we have added, right, it is stored in the array, that value must be converted into number. Okay, so for that functionality we have used this convert array into number. So we will go to this. Okay, we have provided the pointer to that array. Okay, so it will go to the first element. It will check that the number is negative or not, depending on the sign. Okay, if there is minus sign, negative sign, that means the number is negative. Okay, so we will provide this num sign is equals to -1, and we will increment the pointer. So the first will be the number side, and from second position the actual number will start, right? So we are checking that while pointer, like the data is not equals to 0 and data is not equals to pointer, right? Pointer data. And what we will be doing is we will take this number. Okay, subtract 48. Why we are subtracting 48? Because whatever number we are placing, or whatever key we are placing, that is stored as an ASCII value in the array. So ASCII value of 0 is equals to 48, right? So from 48 it will subtract 48 from the number actually. Okay, if it is equals to 0, that means the ASCII value is 48. 48 minus 48, we will get the number. Okay, then that number will be stored in num0. Okay, so let's suppose the number is first number is 0. Okay, so it will be like 0, it will be stored. It will go to the second iteration. Okay, then it will check. Okay, let's suppose first number is 1. Okay, so we'll get 1. In the second iteration, like second number is 5, right? So what it will do is it will multiply first digit, that is 1, into 10. Okay, so we got 10 plus 5, that is 15. Okay, and then we are again here itself only we are clearing the array. Okay, and we are incrementing the pointer. So this way we got the conversion actually from array to digit. Okay, array to integer basically. Now we have incremented the pointer. So we will go over here, that once the decimal pointer is detected, you see that we have added this condition that unless and until a decimal pointer has been identified, you continue to do this operation, right? Normal operations. But if you get the decimal pointer, now we will again check that unless and until we get 0, right? This while loop will continue to rotate. Now in this case what will happen is we will get the decimal pointer into 10 plus pointer num minus 48. Okay, so we will continue to add this number basically. We will multiply that I into 10. Now whatever number we got, right? So the first decimal is of 10, the second decimal is of 100, divided by 100. For third decimal we have divided by 1000. For fourth decimal we have divided by 10,000. Okay, so for that we have done this operation, that is we are multiplying I by 10. Okay, so the default value of I is equals to 1. Okay, now after coming out of this loop, right, what we are doing is we are adding the digit and we are adding the decimal value. Okay, so we are getting the decimal divided by I, so that value will be added into this number and it will be stored into this number. Now you remember that we have this num sign. Okay, so it will check the first element in the array. If it is negative, then means our number was negative, right? So it will get multiplied and the result will be returned. So in this way this convert array into number is operating. Okay, so in this way this function works. Now coming back to this functionality. Okay, now what we are doing is we'll check that result. Okay, so we'll do this calculator function, calc function. So previous var key, what we are passing three parameters, number 1, number 2 and the previous var. Okay, we'll check whatever values we are doing. Okay, so in calc function, we'll go to the calc function. In calc function, we'll check which arithmetic key has been pressed depending on the key parameter that we are passing. Okay, so which function, arithmetic function has been pressed, according to the function we'll get the result. Basically we are calling the function and we are getting the result. Okay, so that result will be displayed, display float. Okay, so we are using this display float function and we are displaying that value on the LCD. Okay, so it will go, we'll again put the LCD cursor on the second line, first column, plus number counter offset plus 1. Okay, so this is for multiple functionality basically. So if we are not pressing the clear functionality, we are not pressing the result functionality, but we are pressing, let's suppose we are entering the number, so it will check that var key is equals to greater than or equals to the 0, means digits. We are checking here we are checking digits, or any decimal pointer has been pressed. Okay, if that is done, we will display the key that has been pressed, and then we will store that key into the array. Okay, so this is the array where we are storing the key pressed. Okay, so that we are doing over here. If the key, both these key, nor the arithmetic keys nor the result key nor the clear key has been pressed, but the sign functionality key has been pressed. Okay, so direct minus sign or plus sign basically. So we'll print that data is minus. Okay, data is minus, and then we will print this functionality. Okay. If no key has been pressed, okay, then we will go that no key is pressed, complete the functionality, clear the data, get the previous results. Okay, and then return. So only display functionality has been remaining, right? So I'll walk you through the display. So the logic is very simple basically. So display position and display number, right? So if the number is greater than lesser than 0, okay, means if the number is negative, we are saying that the sign of the variable is negative, and in the temporary array, the array in which we want to display, right, the first character will be a negative sign. Okay, then we are taking the temp var, okay, which will be equals to num display into sign var. Okay, now num display, it is minus. We are basically inverting the sign of the variable. Okay, num display into temp sign. Basically we are, maybe if the number is negative, we are making it positive. If the number itself is positive, it will remain the positive. Okay, so we want to convert the negative number into positive. That's the purpose of this. Okay, that's the whole purpose of this. Okay, now it will go unless the temp var is become equals to 0. Okay, it will come over here and it will take the reminder only. It will take reminder and it will continue to store into the counter. That is, take reminder, store it in counter, take reminder, store it into counter, and then divided by 10. Okay, again, while counter is not equals to 0, if the counter UI counter is not equals to 0, okay, then it will come over here. It will check if the sign var is equals to 1. It will go and it will add it over here, else it will, yeah, so basically it will store over here basically. Yes, sometimes it is very confusing to understand our own code, so that's why comments are very much important, right? I understand that basically if the sign var is equals to 1 means the number is positive, right? So it will start storing from 0. But if the number is negative, then it will start storing the number from position 1. Okay, so that's the logic over here. Then it will come over here, that is the sign of the value is equals to minus, then it will increment the counter. Okay, and next thing it will do is it will add a decimal pointer. Okay, now adding a decimal pointer over here, what it will do is we are taking only 6 digits of decimal pointer. Okay, or 5 decimal pointer, 5 digits after decimal pointer we want to print, right? So it will multiply, then it will get the remainder, and then it will add it to the array loop. Basically after adding 48, this is adding 48 means we are making it the ASCII value. Okay, then we'll print this float value onto the display. Now coming over here, display decimal pointer, right? We'll check that decimal pointer value is 1. Temp variable, okay. So likewise we are printing this. So we have seen that how we have implemented the key press logic. So we want to integrate the key logic and the LCD logic such that we will achieve the calculator functionality. So first thing we will come like, first we will check, what we will check is what happens when we press the digit keys. Okay, then what happens if we press arithmetic keys, what happens if we press the result key, and what happens if we press on off key. Okay, so the code is divided like that. So if the on off key has been pressed, it will do the clear functionality. Okay, if the result key has been pressed, it will simply provide the result operation. Okay, if the number keys are pressed, it will keep storing the number until any one of the arithmetic key has been pressed. Okay, then it will come over here. Okay, it will check if rest of the key, any of the key has been pressed other than this. Okay, else if okay, else if, see, if any of the key other than the numbers, that means arithmetic key has been pressed, what it will do is it will first convert the first data for first digit or first number into digits. Okay, then it will show that it will enter the one space character. Okay, then it will print the arithmetic key that has been pressed. Okay, then it will again give the space. Okay, so if we see, we will do, what we will do is we will just build this code. Okay, we'll go 1 2 3 4 5. So what I am saying is, whenever we are pressing the keys, right? So whenever we are entering a number, right? So let's suppose like I enter 1 5, right? After we enter the arithmetic key, so you see that there is a space between the arithmetic function and the digit, right? So that is achieved over here. Okay, and even after the arithmetic there is a space, so that is achieved over here. Okay, now what it will do is it has printed the number. Okay, now if number 1 is equals to 0, then number 1 equals to 0, that is display that result is equals to 0. Okay, if number 2 is equals to 0, okay, then what it will do is So basically, like if it is the starting, after starting the calculator, right, it will check that number one value is equals to 0, means there, like, no two numbers have been added, or no two numbers have been entered. Okay, so it will store the first number, or store the first digit or first number into this number one variable. Okay, so the terminology is little bit difficult to understand because I have renamed it like that, but understand that if the num1 value is equals to 0, it will store whatever whatever variable or whatever number we have entered, it will store into that variable, num1 variable. Okay, if num1 variable is not equals to 0, right, it means we have already entered one number, and we have pressed arithmetic key, any arithmetic key, and then we are entering the second number. Okay, so that second number will be stored into this num2 variable. Okay, so this will be stored into this num2 variable. Now what it is doing is, it will store the number into num2 variable, it will display the float. Okay, then it will calculate the functionality, like whatever calculator functionality it will display, because what we are doing is, we are entering first number, then we are entering the second number. So let's suppose I am entering the second number. Okay, we have entered the second number, so it will enter the second number. Okay, now it will do, what it will do is, it will go to the third line first column. Okay, then it will show that number one is equals to result. So whatever result we are getting, it will again store it into number one. Okay, so if I press this first, right, now num1 value will be 30, right, then like we are getting plus, then let's suppose we add 20. Okay, 25, so 30 plus 25 is equals to 55, right. So we can go on adding the numbers, or we can go on doing the arithmetic, right, arithmetic key one by one. So that way our calculator functionality works. Okay, so that is the logic behind this. Okay, now clear the array to store the next number. We are clearing the array to store the next number, then we are resetting the counter. Now whatever arithmetic key that we have pressed, right, it will be stored into previous variable. Okay, so this is the calculator code implementation. I hope you understand. The code was little bit complex to explain. Hope you have understood my explanation. If you have any doubts, post it into comment section. Like my video, subscribe to our channel, and share with your friends. Thank you for watching.